Most circle questions have to do with the area and the circumference of the circle. The CLT gives you the formula for the circumference and area of a circle on the math formulas page of the quantitative reasoning section, the math section. If you want to review those basic concepts, fast forward to the final section of this video where we'll do some basic area and circumference videos. But now let's talk about arc lengths and sector area. These are questions about a certain portion, a fraction of the circle. A circle with a 90-degree central angle shaded like a pizza slice. What is the area of this sector of a circle with a radius of 4? Well, we have to find the area of the circle first, right? 4 squared pi, that's 16 pi. Now, what's the area of the sector that takes up 90 degrees? Well, there are 360 degrees in a circle, so we have 1/4 of our circle. 90 over 360 times 16. 1/4 times 16 is 4, so 4 pi. That's the area of the sector when the central angle is 90 degrees. Let's talk about arc measure. What is the measure of an arc whose central angle is 60 degrees when the radius of our circle is 4? All right, so we have a circumference question now, but a portion of the circumference, right? So 2 pi r is 8 pi. That's the whole circle, 8 pi. But we only have a fraction of that to make up our 60-degree arc. In fact, it's 60 over 360. So we have 1/6 times our circumference, 8 pi. So we have 8 over 6 pi, which reduces to 4/3 pi. That's the length of the arc. It's a portion of the circumference. Now practice this question by pausing the video before you listen to my explanation, but be warned, there is a little trick in the wording of this question that you need to look out for. A circle has a circumference of 24 pi. A central angle of 120 degrees cuts off a sector. What is the area of the sector? All right, pause the video, try to answer this question, and then watch my explanation. So the trick here was that we gave you the circumference, not the area. So you needed to notice that the radius of this circle was 12 and then find the area. 12 squared pi, which is 144 pi, and then 120 degrees is our central angle. So we are looking for 1/3 of the area of the complete triangle. So 1/3 times 144 pi, that should give us 48 pi, which will be answer B, the correct answer. All right, a super rare and advanced topic, the unit circle. What is the unit circle? Well, if we draw an XY coordinate plane, the unit circle has its center at the origin and a radius of 1. So it's a circle drawn in the XY coordinate plane with a radius of 1 and a center of 0, 0. So the radius of this circle is 1. That's why it's called the unit circle. And you'll notice that the points 1, 0, 0, 1, -1, 0, and 0, -1 are all on the unit circle, which makes sense because it has a center at 0, 0 and a radius of 1. Big whoop, right? Why does anyone care about the unit circle? Well, the unit circle actually helps us understand trigonometric ratios really easily, sine, cosine, and tangent, because if we draw a line from the origin to any point on the circle, we can make a triangle with a hypotenuse of length 1. All right, hang on, you lost me. So we've got a circle with radius of 1, but the whole point is that there are triangles. Yeah, that's kind of right. Let's start by drawing a 45-degree angle from the origin up to a point on our circle. Now, you'd agree that the length from the origin to the circle is 1, right? Of course you would. Now, let's draw our triangle. This is a right triangle, and it should tell us how far along the x-axis we've made it and how far along the y-axis we've made it. Remember, we have a 45-degree angle at the origin a 90-degree angle, and another angle, which must be 45 degrees because there are 180 degrees in a triangle. So we have a 45, 45, 90 triangle with a hypotenuse of 1. What are the lengths of the legs of this triangle? All right, we're starting to get in the weeds here, and if you're learning this for the first time, you're probably confused. So let's do a quick review before we finish. The unit circle is a circle with its center at the origin and a radius of 1. We use the fact that it has a radius of 1 as a quick guide to understand what the value of cosine and sine are at certain measures of a degree. Back to our example, we have a 45, 45, 90 triangle with a hypotenuse of 1. A squared plus b squared equals 1 squared. But remember, it's a 45, 45, 90 triangle, so a and b are the same, so we can use the same variable for them. A squared plus a squared equals 1 squared. Now we combine like terms, so we have a squared plus a squared. That's 2a squared equals 1. A squared equals 1 over 2. Take the square root of both sides, and we get a is equal to the square root of 1 over the square root of 2. Square root of 1 is just 1, so we have 1 over the square root of 2. Now, we don't like to keep roots in the denominator, so we need to multiply this term by 1, because multiplying anything by 1 keeps it the same. And so we can multiply it by the square root of 2 over the square root of 2, which is just 1, in order to change how it looks. And we get square root of 2 over 2, which is the exact same as 1 over the square root of 2. All right, that was a lot of work to determine that the length of our sides of this triangle was square root of 2 over 2. And what did this tell us? What did we gain from this? Well, remember, this triangle's on the unit circle, and we are square root of 2 over 2 x units away from the origin. And we're square root of 2 over 2 y units away from the origin when we have our radius going 45 degrees out from the origin. So we label this point x square root of 2 over 2, y square root of 2 over 2. And I promise you we're not doing this to confuse you. This will help you get some of the more advanced questions that you might see on a standardized test correct. And it will also help you if you really understand what the unit circle is in any math class that you're taking. All right, back to our triangle. We have this point, square root of 2 over 2, square root of 2 over 2. And that is 1 unit away from the origin because the radius is 1, and we determined by using the Pythagorean theorem that the x value was square root of 2 over 2 and the y value was square root of 2 over 2. So what would cosine of our central angle, 45 degrees, be in this situation? Well, it would be the square root of 2 over 2 over 1. And that is the whole point of this exercise. Cosine of the central angle theta is equal to the adjacent side over the hypotenuse. The hypotenuse is 1, and the adjacent side is the x-axis. The x-axis is the adjacent side, and it gives us square root of 2 over 2. That's super important. Cosine is the x value because cosine gives us the adjacent side, and that's our x-axis. So this is a huge takeaway both for your CLT and other standardized tests and math class. Cosine of theta in the unit circle corresponds to the x-coordinate because the x-axis is the adjacent side to that central angle theta, and believe it or not, this is actually super helpful. What is sine of theta? Well, that's just the opposite side over the hypotenuse, But the opposite side is just the y value, how far up we have gone. And so the y value in the unit circle is the sine value. So after all of that, let's do a practice problem. For an angle theta in the standard position, the terminal side intersects the unit circle at point P. If sine of theta equals the square root of 3 over 2, what is the y-coordinate of P? Now that's a lot of jargon, but remember sine of theta already corresponds to the y value. So the correct answer here is just the square root of 3 over 2. This has been the entire point of this exercise. There is one level further, which is understanding that the unit circle is also divided into quadrants, and they're very, very simple. Quadrant 1 is in the top right, and then quadrant 2 is top left, bottom left is quadrant 3, bottom right is quadrant 4. So all you need to remember is that quadrant 1 is in the top right, and then you go counterclockwise. Or that quadrant 1 is in the top right, and you go left. Either way, it works. For an angle theta in the standard position, sine of theta is negative square root of 3 over 2, and cosine of theta is negative 1 over 2. What quadrant does the terminal point P from theta's terminal side lie in? And if you've never heard of this before, now you're really confused. But remember, cosine is just x, sine is just y. So here, x is negative, y is negative. The only quadrant this can be in is quadrant 3. And if you're interested in practicing this more, use the free study guides at app.classictestprep.com. But as promised, here are some basic area and circumference questions if you're interested. A circle has a radius of 3. What is its area? Pause the video and solve it before listening to my explanation. Well, area is just pi r squared. R is 3, so the answer is 9 pi. A circle has a diameter of 8. What is the circumference? Diameter is twice the radius, so the radius here is 4, and our circumference is 2 pi r, so 2 pi times 4, 8 pi gives us the circumference. That's it.